Greetings, learners. Welcome to the climate and weather lesson. We are going to be looking at mid-latitude cyclones, particularly the development stages, and we'll be integrating them with synoptic weather maps. I'm going to be touching more on the integration part with synoptic weather maps. So I would assume that at least the characteristics of each of the stages is something you have heard before in class. Please get your pen and paper and be ready for the lesson for today. Let us get started. First, I want to start with frontal boundaries, because once you mention fronts, they are one unique characteristic of the mid-latitude cyclones. So here we have got about 4 fronts, and most learners are familiar with only 3. Now I want to talk about the cold front, the warm front, the stationary front, and the occluded front, okay? But basics, first things first. What is a front? There are many ways of defining a front, but the key concept behind that definition must revolve around it is a boundary or a transition zone between 2 different air masses. Or you can even say between 2 air masses that have got different characteristics. Or, if I can take you back a little bit, remember these 2 different air masses are cold air and warm air. And cold air has got different characteristics compared to warm air. Now, fronts are typically, as I said, you're most likely going to associate them with mid-latitude cyclones. They are typically associated with mid-latitude cyclones. But with experience, I can confirm that they may occur independently and not necessarily as part of the system. Now, the cold front. The cold front on a synoptic weather map will be symbolized by the triangles, meaning that is the symbol that you are likely to get. It will be in triangles. There is no other symbol, so don't confuse these learners. It will be the triangles. And in this situation, you know that this is a symbol that you will find in the synoptic weather chart. Do not take this symbol and also move it to drawing of the cross section. Your answer will not be correct there. So this is only in the synoptic weather chart. Now let us look at the warm front. The warm front will have half moons. Can see those nice symbols there. Half moons. There's a difference between this, which is a triangle, and that, which is a half moon. So that is a warm front with a half moon, and a cold front has got triangles. Remember, to enrich you again, behind the cold front, you will find cold air. It is called a cold front because it is pushed by cold air. And warm fronts are called warm fronts because they are pushed by warm air. Behind the warm front, there is warm air. Now let us move on to the occluded one before we take the new one into consideration. Okay? In the occlusion, remember the cold front has undercut the warm front. It has lifted the warm sector. So your symbols there will have, there's the triangle for cold air, and there's the half moon for warm air. There's the triangle for cold air, there's the half moon for warm air. So that is an occluded front. Now, this front has got more information that you can take out, okay? Assuming this is in the southern hemisphere, okay? So this part here is called the apex, okay? That is now facing south, okay? So if your occlusion starts with this symbol, that is the symbol of the cold front. So that will be a cold front occlusion, okay? If the first symbol from the point that is called the apex is that of a cold front, then that is a cold front occlusion. Likewise, if the symbol is that of a warm front, That is a warm front, occlusion. So this is an occluded front, and to spread your wings a bit, this is actually a cold front, occlusion. I will deal with occlusions a bit later. What I want to highlight as well is that, please note that these symbols, as you can see here, are all on one side. They are all on one side of the front, okay? Now let us take the stationary front. I'm very particular with language, although I don't mark English when I mark geography. But that stationary, take note, it is not the stationary that you use as textbooks, counter books, and exam pads. But it is a stationary, meaning it is not moving. It is not moving. Also in this case, you've got the cold front sign, but now the half moon is on the other side. That is the difference between the two fronts, the occluded front and the stationary front. Weather is very dynamic. Although the cold air has got properties like higher molecular density, heavier air, more aggressive, and warm air is lighter, can rise, there are moments where the front cannot move. And it does happen. It is an occurrence that you sometimes find in weather. It is represented by a stationary front. Now that you know the fronts, let's move on. Okay? Mid-Latitude cyclone development. Stage 1. I know you know that by now because this is the last push and we are going for your exams now. The name for stage 1 is the initial stage. Okay? It is the initial stage. Initiate, start, initial stage. Okay? Now, often in this stage, we identify warm air. There's warm air, okay? There's warm air. We identify warm air. And the warm air comes from the tropics. That's why it's in the upper side of the drawing, okay? And the cold air that you see there comes from the poles. In the southern hemisphere, that will be the South Pole. Remember, this stage here, the initial stage, is a theoretical stage. You will not be able to pinpoint it when you look at your synoptic weather map. In other words, we assume that the cyclone starts this way, but we cannot produce such in the synoptic weather chart. Okay? So, alternative name, this is called the initial stage. Don't call it stage 1 in the exam. Call it the initial stage. I often like to refer to this stage as the cyclogenesis stage. Remember, cyclone, referring to a low pressure in the southern hemisphere that has got a clockwise circulation. Genesis, you can refer that to the Bible, where it relates to the creation, the beginning of, or the start of. So cyclogenesis, meaning the beginning of the cyclone. You are free, however, to refer to all the stages of development as cyclogenesis, although in truth, the beginning of the cyclone, cyclogenesis, is the initial stage, which is the first stage. Now let's move forward a bit, okay? The front that you see there separates the warm air and the cold air. So any transition zone that separates two different air masses shall be called a front. And this one is specific. We'll call it a polar front. Don't just call it a front. We'll call it a polar front, okay? That is a specific name. It's a geography name. If you use that name, you'll get marks. It's called a polar front. Now, that's the problem. Remember that the polar front will not remain straight forever. It will be disturbed. The moment it is disturbed we are now moving to the next stage, which is stage 2, but it's got a name. It's called the developmental stage, or you can refer to it as the wave stage. Now you can see the wave there. You can see the wave there. That's how it shows in the synoptic weather chart. The examiner is also very interested in why the polar front was disturbed. Quickly, we'll give you 4 reasons. 4 reasons. Number 1, remember we had warm air that came from the tropics, okay? Now, cold air was coming from the polar region. So the first reason is that these air masses have got different temperatures, okay? Different temperatures means different properties, okay? Remember, cold air has got different properties from warm air. And cold air and warm air cannot mix, okay? The second reason, okay, that was reason number 1. The second reason is that they've got different origins, meaning the warm air that you see, you need to specify that it comes from the tropical region, okay? That's an additional mark in the exams, because you're not only talking to me about the temperature, but you're also explaining further and talking about the origin. Now, the cold air that you see, again, I've mentioned cold, but it's got different origins, meaning it is from the polar region. Now let's take reason number 3 for the disturbance of the polar front, okay? Reason number 3 says this front will be disturbed because cold air has got a different speed compared to warm air. Different speeds. Remember, cold air is faster and warm air is slower. But there's no way that front can be balanced. There's no way that front can be balanced. Okay. We now move from stage 1, which is the initial stage or the cyclogenesis stage. We move to stage 2. Now, stage 2 is called the developmental stage. You can also call it the wave stage. You can see clearly the wave there, okay? Now, there is a disturbance in the polar front, because the polar front cannot remain straight forever, okay? No, stage 2 then will be called the wave stage, because the polar front is disturbed and it changes the shape and forms a wave. The other name is called the developmental stage. But the examiner is often interested in what disturbs that front. Now you must produce 4 reasons why that front is disturbed. Okay? Let's go for those reasons. Reason number 1 is different temperatures. Okay? Remember, we're talking about warm air. There's warm air. There's warm air. And we're also talking about cold air. And there's cold air. These 2 different air masses have got different temperatures, and of course, number 2 will be different origins. You must now also say that the warm air is from the tropics and the cold air is from the polar region. Now we take reason number 3. Reason number 3 is different speeds. Remember that cold air is faster, okay? Higher molecular density, heavier, more aggressive, and faster. But warm air is very slow. So once the speeds are not the same, that front will be disturbed. And the 4th one, remember, mid-latitude cyclones originate over the ocean, but they move to areas that may also have coastal areas, meaning the shape of the coastline is going to affect the shape of the front as well. In other words, it will disturb the polar front. So there your 4 reasons are, and the examiner is very interested in them. Make sure you master those. Already, if you can peep into the future, you will see that the clockwise circulation is beginning to develop already around the low pressure that you cannot see very clearly, but there is an indication that it's getting there, okay? So it is now a precursor to the next stage, which is stage 3, known as the mature stage. There's no alternative name here. It is known as the mature stage, okay? What sets the mature stage apart? You may note this because it is very, very important. Number one, you can see that the low pressure center is very clearly developed there. See the apex, the point there at the bottom, okay? The low pressure center is clearly developed. The warm front and the cold front are separated from each other. There are separations at the center of the two, you get a low pressure. The clockwise circulation is well developed. In other words, you can say it has intensified, or you can say it has become clearer. It is well developed. Now, this is the stage where you can also tell different weathers as applicable to the cold front, to the warm sector, and to the warm front. Please be familiar with those weathers and also master that, because in almost all the question paper that I've seen, the examiner does ask about that one, okay? So we move from the mature stage to the last stage, which is the occlusion stage. That is the last stage, which is the occlusion stage, okay? That is the last stage of a mid-latitude cyclone. Here the cyclone finishes. It is going to be the end of the cyclone, okay? What happens here is that the cold air behind the cold front, remember the cold air moves faster, and the warm air in the warm sector is very, very slow. So the cold front catches up with the warm front and wedges itself under the warm air. Now, if we were to do a drawing of this, it would be very interesting because you've got different types of occlusions. But what we need to understand now is that the cold front is pushed by cold air. There is cold air behind the cold front. It moves faster. And then it catches up with the warm front, meaning it lifts the warm sector and also lifts the warm front. So it wedges itself under both sectors, the warm sector and the cold sector ahead of the warm front. That is called the cold front occlusion, or you can say now it's an occlusion until we clarify the difference between cold front and warm front occlusions. Let me highlight something now, okay? In this occlusion, as you can see there, the two symbols are together along one front, meaning that is an occlusion. But the symbol that is closest to the apex is actually that of a warm front, meaning that is a warm front occlusion. Let me say that again. The symbol that is closest to the apex is the one that determines your naming of the front. In this case, the half moon, which is closer to the apex, means this is a warm front occlusion. Let us see if we can integrate that into a very simplified synoptic weather chart, okay? Remember I said the initial stage, cyclogenesis, where the cyclone starts. You cannot really illustrate it. It's an assumed stage. So we will have here the wave stage as illustrated there. Now you can see it's just a wave, okay? Now look at the mature stage. There it is, clear cold front, clear low pressure, clear warm front. Of course, we don't have the arrows to show the circulation, but you are now a student that is enlightened. You know that the warm sector must show warm air, and the cold sector must show cold air, and they must all together show a clockwise circulation. Now look at the occlusion stage as identified there. Clearly, there is a symbol here for the warm air, which is the warm front, and the cold air, which is the cold front. So that is an occlusion stage. A very interesting question that can come out of here. I think it was in the 2023 November NSC exam from the DBE. But how do you identify this pattern? How do you name this pattern? Remember, I'm going to do a very simple drawing. Maybe you have that guy there. I hope my drawing is clear. And maybe there's a lady there that is holding hands with the guy. Maybe here you have got another little one that is holding hands with the father. And another little guy here that is holding hands with the mother. Now this is a family, hands joined together. Now look at this. Cold front, joined to the warm front. Cold front, joined to the warm front. Cold front, joined there. So this is a family pattern. And that is an exam question. Please be familiar with that. There's more that we can do, but I'm just hitting the basics so that you can catch the easier marks that you can get, okay? Let's move on to the next one. I want to check if you are all good here, okay? So you draw this quickly, just 2, 3 straight lines, and then you put the symbols so that we can identify the concepts if you have grasped them very, very well, okay? Now I want you to show me and label that. What is that, okay? Label it, okay? If you have done well, it should have a label like that. Isobar, because that is a line that joins all places with equal or with the same atmospheric pressure. So you need to name that, okay? Now show me something. What is happening there? Yes, I know that is the apex, which is that point there where the cold front meets the warm front. But I need to know the type of pressure, okay? Put it in, and if you have done well, that should look like the low pressure, okay? The low pressure, the low pressure. Please label it well, okay? And then we can now jump, because that one is well known, cold front, that is well known, warm front. But the labels must be there. Dear candidates, please, if you can, write it in full. Cold front, don't just write CF. Don't just write WF. Cold front in full if you can. Warm front in full if you can, okay? Now show me the circulation, okay? Yes, we can see it. There it is. There it is. There it is. There it is. But I want you to tell me the type of circulation, okay? If you're correct, then you know a low pressure in the southern hemisphere will have a clockwise circulation. Please mark my words. Don't make the mistake that I often see in your exam papers where you say clockwise movement. It's not a movement. It is circulation, okay? Now, show me the warm sector. Label the warm sector, okay? Just put a WS. Show me the warm sector. There it is. If your label is correct, your warm sector should be somewhere there. There's the warm sector. There's the warm sector. And then we will finish off by you showing me the cold sector. The cold sector is the place where you find the cold air. There is the cold sector, okay? Now we'll jump. What I want to highlight here is that is a mid-latitude cyclone in its mature stage in the southern hemisphere. Please be careful. The examiner is at liberty to use the northern hemisphere as well. So please be familiar with these two drawings or with these two approaches. Practice, get the circulation right, know where the warm air is, where the cold air is, and master it, okay? Though that is your occlusion, as I said, there's the cold front, warm sector up, okay? Cold air and the warm front lifted. That is a cold front occlusion, okay? Please practice the two different types of occlusion. This is a cold front occlusion, and this is the warm front occlusion. You can see the warm front remains in contact with the ground. However, in the drawing on top, thank you for attending the class, and please make sure you read and you practice and you revisit your question papers like this one. Please make sure you revisit it and answer the questions. Otherwise, study hard, get ready for your exam. The warmer your blankets, the colder your future.